So Google was not our friend yesterday, trying to get Classroom to work, trying to get Docs to work. So people were having a lot of issues with some of that stuff yesterday. So let's see, chapter 13 notes. This is where we left off yesterday. We went through these. We did the practice problem, and then we've got Avogadro's principle to go to. Okay, so that's where we're at. And then you had open. We had 13.1, I think was your homework. Yeah, here we go. So just want to go through a few of these problems with you and see, how you're doing with these. So that's primarily like what we're going to be working on today. And then tomorrow we'll get into Avogadro's principle and some other stuff. Okay. So Boyle's law here, when we go through this, we've got a balloon filled. So in your packet, you should find the notes from yesterday. And then if you go several pages in, you're going to see 13.1. Yeah. All right. So Boyle's law is P1 V1 equals P2 V2. Just to kind of recap the law from yesterday, if our pressure or if our volume is decreased here, then our pressure increases. And I showed you kind of with my vernier probes, if you watched the video yesterday, I showed you about that. If you think about like a balloon, for example, okay, if you take a balloon and then you squeeze the balloon tighter, and take up less space in there, the pressure exerts, and you can eventually get to the point where if you do that enough, the balloon will pop because the pressure exceeds the capacity of the balloon. So that would make sense, I think. Oh, I can't stop yawning. All right. So here we've got a balloon. It has, this is our initial volume. So this is V1. P1 then is here. They're releasing it, and our P2 is going to become this. Now, a couple points. First of all, you need to make sure that your pressures here and here are in the same unit. If they're not, you go back to the notes from yesterday and you look at those standard pressure values and use that to convert. Okay, so I gave you these standard pressure values yesterday up here. Each one of these things equals the other. So you can use these as conversion factors because this equals this. Okay, so you can convert from unit to unit if you need to. These values, whatever you would need for these standard pressure values, those will always be given to you on a test. And if you take AP, the ones that you need for AP are actually given on your formula sheet by the AP company. So you don't have to memorize these. Some of these you might accidentally memorize just because you use them enough, but you don't have to. The other thing that I should have told you about yesterday on the video that I neglected, and I realized it's 5th hour, and I apologize, is something called STP. Okay, so STP, what that stands for is standard temperature and pressure. Okay, these are all standard pressures. So all of these would be your standard pressures. Okay, so pick one, whichever unit you need to use. Standard temperature then equals 273 Kelvin. So if they say that at STP, you would know that it's 1 atmosphere and 273. Does that make sense? So they'll say standard temperature and pressure. And I don't know why they pick that, because like standard temperature, that's 0 degrees Celsius. Like that's cold, you know? So it's never quite made sense to me, but that's what they do. That's what they picked. All right. So those are our standard pressures. Okay. So if we plug these into our formula, and it's always good, like if you're struggling with these problems, it's always good to identify while you're reading through them what each thing is. What is this variable? This is V1. What is this variable? This is P1. So when you go back to plug them into your equations, it makes it easier. So here my P1 is 1. My V1 is 500. And again, like I said on the video yesterday, you don't have to convert this into liters yet, but when we get in another couple formulas, that has to be in liters, no question asked. So start getting in the mind frame of like seeing this and giving your brain a little alert, like, oh, I'm gonna have to do something with that. Okay. My P2 is 0.5. And I'm solving for V2. So 500 divided by 0.5, you probably do that in your head. I don't know why I grabbed my calculator. 500 divided by 0.5. Yes, no, maybe. You can do it with the calculator if you want. 1,000, right. Okay. So this is going to be 1,000. I'm not going to put a decimal point at the end here because this right here is 1 sig fig. So since this is 1 sig fig, even though these are 3 sig figs, this is 1 sig fig. I'm only going to have 1 sig fig in my answer. By not putting a decimal point here, I've got 1 sig fig. Now I still need these zeros because they're placeholders. I still need them, but I only need 1 sig fig in my answer. Okay, does that make sense? Everybody cool with that? Okay. All right. Charles's law then relates temperature and volume. So he is V1 T1 equals V2 T2. Now here, again, the volume isn't a big deal. We can keep that in milliliters, but the temperature is a huge deal. We have to convert this into Kelvin. So we're going to take this and we're going to add 273 to it to get 298. Here, we've got to add 273. Oops, 73. It's 323. Oh. Yep, 323. So that's going to equal 323. You have to have these in Kelvin in order for this to work correctly. Okay? If you don't have it in Kelvin, you will not come up with the correct answers. Okay? So now we're going to substitute this in. These are my initial values. So they are going to go in on this side. And this is my T2 value. So V1 is going to be 752. We're going to divide that by 298. We're solving for V2, and our T2 is 323. Okay, so I'm going to cross multiply. And then I'm going to divide by 298. So V2 equals, oh, hiccup. And that's going to be milliliters because my volume was milliliters up here. Okay? Yes, sir.
What did you get that?
To get this?
Yeah.
I cross multiply. So I multiply this times this. So 323, yeah. So that ends up being 242,896 equals 298 V2. And then I divide both sides by 298. Oh, algebra, sweet algebra. How do I love thee? Let me count the ways. So now you've had algebra and Shakespeare. All right, does that make sense, Ernesto?
Yeah.
Or algebra? Okay, so cross multiply, so cross multiplied, and then I divide. All right, any questions about Charles? If you've ever had a balloon inside that's blown up and you take it out in the middle of the winter outside and it's cold outside, what happens to that balloon? Yeah, it shrinks down, okay? Then you take it back into the house or into a warm environment and it increases again. That is Charles's law right there. Okay? All right, so that takes care of that one. Now, Gay-Lussac then related temperature and pressure. So his was P1 T1 equals P2 T2. Okay, now again, our values here have to be in Kelvin, and we just did this one up above for that value. This one ends up being 325, I think. So 52 and 273. Yeah, 325. Okay, so you got to convert those into Kelvin before you can get started. All right, this is my P1. This is my T1. And this is going to be my T2. So it's always good to identify what your variables are in the problem. So it makes it easier for you to place them in here. Okay. Now Ernesto, for some people, it's easier for them to cross multiply with the variables first. So that it would end up being P1 T2 equals P2 T1 and then sub in. You see what I did there with I cross multiplied the P1 T2 and then the T1 P2 is right here. So some people, it's easier to do this first and then sub in. It doesn't matter which one you do. You're going to come up with the same answer if you do it right. Okay. So let's plug these in. This is 3. This is T2. The problem with this is that you're flipping, you know, so you got to really pay attention to where you're grabbing your numbers from if you cross multiply ahead. That's why I don't like doing that, but some people do. So I show you both ways and you can figure out which one works for you. You just got to be super careful to make sure that you have these things flipped around. Yeah.
Isn't it 325, not 352?
Yes, it's 325. It's because I'm not getting enough oxygen to my brain. There we go. Better? Thank you, Lydia. Good call. Good call. Catch me on these things. All right. Here we go. Dyslexia at work. Okay, I'm going to multiply that by 3 and divide by 298. And I should end up with 3.27. I need 2 sig figs here for my answer. So P2 is going to equal 330, but I can't get, yeah, that will give me 2 sig figs. And that's not right. That is 3.30. There we go. And that's going to be ATM. Boy, I am just missing values and decimals and all kinds of stuff this morning. Sorry, you guys. And apparently I can't spell. There we go. All right, good. Ready? Everybody cool? Ready to move on? Okay. So the next one is the combined gas loss. So we take all three of these guys and we combine them into one. So this becomes P1 V1 over T1 equals P2 V2 over T2. So we need to identify what each thing is. So this is in liters. That's good. That's going to be our V1. This is our T1, but what do I need to do? What's bad about this? Kelvin. I got to get this into Kelvin. So that's 298 Kelvin. And then this is going to be my P1. My volume is going to be my V1, that or V2. That is what I'm going to be solving for. So we don't know what this is. We're solving for this guy. This is our P2, and this is our T2, but what do I got to do? 283 Kelvin. Okay, good. All right. Let's see if you could sub in and solve for V2 here. Well, I continue to yawn. Oh, goodness. Cannot stop yawning. Oh, Lippy's not doing your calculations for you anymore. You gotta grab your calculator and do it yourself now, huh? Poor things. Oh, Lippy. All right, did you get it set up right? 283, 1.8, 50. All right. Did you get 2 sig figs? V2 equals 50. No. I got around 60 point to give me 2 sig figs liters. 60 liters? Everybody good?
Wait, why is there only 2 sig figs here?
Right here.
Oh, okay.
I knew there was. All right. Converting to the Kelvin scale. When we convert to the Kelvin scale, we're going to take our degrees Celsius plus 273 is going to give us Kelvin. So I'm going to make you do that on your own because that should be easy. Okay, and then degrees Celsius is going to equal Kelvin minus 273. Now, none of these values are going to be negative. You won't have any negative answers. So no answers will not be negative. No negative answers. I am not writing this down right. No negative answers. You won't have any answers here that are negative. Down here, you're going to end up with some negative ones. But up here, you won't. Because Kelvin can never be negative. If you have a negative Kelvin, you goof something. Or I goof something right in the problem. I've actually done that before, to be honest with you. But you should never end up with a negative Kelvin amount because remember, that is talking about absolute zero. Absolute zero is where all molecular motion stops. You can't have negative motion. Okay? Like you can't have less than it not working. All right. Down here, these are mixed practice. So you're going to have to go up to these problems and you're going to have to figure out which of these laws you're going to use. Now, how do we do that? Well, let's look and see. First of all, you can use the combined gas law for every one of these. Okay? So here, you're given volume and you're given pressure. So this is going to be Boyle's, but you could use the combined gas law. Okay? So let me show you how you use the combined gas law for this guy, even though there's not temperature here. Okay? So if I have P1 V1 over T1 equals P2 V2 over T2, okay? They didn't tell me what my temperature was, right? Give me a temperature. 10. Okay? Let's do 1. Let's do 1 Kelvin. It's even easier, right? Because it's even easier to multiply or divide by 1. Okay? Well, let's just pretend that this is at 1 Kelvin. So now we're going to plug in what we know. Well, P1 is here. So that's 737. V1, they gave me here, which was 50. My temperature is at 1 Kelvin. My temperature didn't change, so it's still 1 Kelvin over here. And my P2 is 790, and I'm solving for V2. So do you see how you can use the combined gas law for this? Whatever the variable is that you weren't given, like for, you know, both, like if the other one's, one of them's held constant, just make it 1. Or you can go up and try to figure out which gas law you want to use. Either way works. The other thing that I needed to talk to you about on this problem was this right here in particular. Okay, this says at STP. Remember, at STP, You can figure out whichever pressure you want. You want that pressure to be the standard pressure that was listed in that notes table for this. So here that's going to be 760 millimeters of mercury. And your standard temp is what? How much is your standard temp? What did I tell you that value was? 273 Kelvin. Okay? So when it says at STP, so down here, they've asked you at standard pressure. So you're going to find the standard pressure that equates with millimeters of mercury. So for tonight, you're going to finish this sheet up. So you got time in class to work on this and then just finish this up. That's what I wanted to work on today, was just making sure you knew how to use these gas laws. Okay? Ooh. Yeah, let me get you past that. Here you go, ma'am. Okay, let's see here. I need to go here. I'm going to stop recording.